On July 17, 1981, 114 people died in a Kansas City hotel atrium. The cause? A single connection. This is load path. One structure, one connection, the load that unzipped it. One box beam hanger rod connection, overloaded beyond its strength. The collapse happened under loads far below what the building code required. How could that be? Steel rods were meant to run continuous from the roof, each supporting one walkway. But the fabricator cut the rods. Each walkway got its own. That doubled the load on one connection. The revised detail made the fourth-floor connections carry both walkways. Demand double. Why did the engineer approve a change that doubled the load? He signed off without recalculating. That approval meant the fourth-floor connection now held two walkways. The arithmetic was simple. Original carried 1, revised carried 2. The connection was sized for one walkway, not two. Dancers filled the walkway. Each connection carried far more than it was built for. The nut and washer pulled clean through the box beam flange. A thin plate, a washer, and a nut bore the entire walkway. The doubled load bent the flange. The washer slipped through. The NBS report, under-designed for the doubled load. Pull-through. One pull-through. Then the walkway dropped, snapping the second-floor connections. Why did one failure bring down the whole walkway? The first failure at the east end. Load redistributed to no stronger neighbors. Each connection failed in turn. The falling walkway slammed into the second. In seconds, the whole structure lay in ruins, set by one under-designed connection. The report forced the profession to admit a simple change went unexamined. The verdict: loads substantially less than the code design loads. No one checked the change. Picture the Hyatt Regency's atrium, a soaring, glass-ceilinged space. 3 suspended walkways crossed at different levels. On a busy Friday evening, hundreds gathered for a dance contest. The atmosphere was festive, unaware of the structural flaw overhead. The original design used long steel rods from the roof. They passed through the fourth-floor walkway and continued to the second. Each rod was one continuous piece. The fourth-floor connection only carried its own walkway. Now the fourth-floor connection held both walkways. The load doubled. The box beam, nut, and washer were sized for one walkway, not two. The connection relied on a nut and washer bearing against the bottom flange. That flange was a thin plate, perhaps half an inch thick. It was designed for one walkway. Now it had to support two. The load path was straightforward. The walkway deck transferred weight to the box beam, which transferred it to the rod through the nut and washer. The entire weight of 2 walkways hung on that small bearing area. Any weakness there would be catastrophic. As dancers filled the walkway, the load increased. The thin flange began to deform, bending downward. The washer and nut started to pull through. A slow, silent beginning. When that connection failed, its load was suddenly redistributed to the adjacent connections. But those connections were identical and equally overloaded. They couldn't handle the extra load either, so they failed too, one after another, in a rapid cascade. With multiple connections failed, the fourth-floor walkway broke free. It plunged downward. In its fall, it struck the second-floor walkway below, adding its immense weight to that already overloaded structure. The second-floor walkway couldn't withstand the impact. Its connections failed. In seconds, both walkways lay in a tangled heap. The collapse killed 114 people and injured 216 others. It was one of the deadliest structural failures in U.S. history. The victims were not just numbers. They were dancers, spectators, and hotel guests enjoying a Friday evening. Their deaths were caused by a single overlooked connection. The National Bureau of Standards, now NIST, investigated. Their May 1982 report concluded the most probable cause was insufficient load capacity of the box beam hanger rod connections. They pinpointed the design change as the root cause. But how much load was actually on those connections? The code required the walkway to hold a certain weight per square foot. The original design met that requirement, yet the collapse happened at a fraction of that load. So the connection wasn't just overloaded by the change, it was under-designed even for the original code. The load path depended on the bearing area of the washer on the flange. A standard washer has a small surface area. With one walkway, it was enough. With two, the stress doubled. The steel couldn't handle it. The first sign of trouble was a hairline crack in the flange, invisible to the naked eye. As the load increased, the crack grew. The washer began to tilt, concentrating stress on one edge. Then, with a sudden pop, the washer punched through. The connection gave way in an instant. When one connection failed, its load transferred to the neighbors. But those neighbors were already overloaded. They couldn't take the extra load. So they failed too, one by one. The entire fourth-floor walkway lost support within seconds. With multiple connections gone, the fourth-floor walkway broke free. It fell, gaining momentum. It slammed into the second-floor walkway below. The impact was enormous. Both walkways crashed to the atrium floor. The collapse lasted only seconds. The aftermath was devastating. 114 people died. 216 were injured. The walkways lay in a tangled heap. Rescue workers searched for hours. The NBS investigation focused on the connection, not the overall structure. They tested materials, analyzed loads, reconstructed the failure sequence. Their conclusion was clear. The connection was under-designed for the doubled load. The design change was the root cause. The report sent shockwaves through the engineering profession. It showed that a simple, unreviewed change could have deadly consequences. In response, the industry adopted stricter requirements for independent review of structural changes. The lesson was clear. Every detail matters, and no change is too small to check. After Kansas City, independent review became the norm. Now you understand the exact failure. The next load path is already on the table. Our next video. Subscribe.